We're now going to look at finding the distance between any 2 points on a real number line. Suppose we have 3 points, P, R, and Q. Further, suppose that we want to compute the distance from P to Q. Well, basically, P is at -5. So we're standing here at -5, and we need to ask, how far do I have to travel before I get to 7? We literally, all we have to do here is count the number of tick marks that I would have to travel to get from -5 to 7. So from -5 we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 tick marks. So the distance from P to Q is 12. Now, is there any way that I could find that result without having to draw a real number line and count the number of tick marks? And the answer is yes. To find the distance from P to Q, what I could do is I could take the absolute value of the P value, which is -5, and subtract from that 7. So the absolute value of A, if you think about it, minus B, where A is the point P and B is the point Q. So the absolute value of -5 minus 7 is the absolute value of -12, which is 12. Now a logical question to ask is, well, if it's 12 units from P to Q, how far is it from Q to P? Well, to find the distance from Q to P, now what I'm going to be doing is taking 7 minus a -5 in absolute value, which is the absolute value of 12, which is, again, 12. So that should be reasonable that the distance from P to Q is the same as the distance from Q to P. Let's look at one more example of this. Suppose I wanted to find the distance from Q to R. Again, just using pure logic, here I am at Q. How many tick marks do I have to go to get to -3? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the distance from Q to R is 10 units. Using our formula, I would take the absolute value of 7 and subtract from that -3. 7 minus -3 is the same as 7 plus 3, so I'm computing the absolute value of 10. The absolute value of 10 is 10. I'll leave it to you to verify that the distance from R to Q is also equal to 10.